Okay, so often in combination with scientific notation is this concept of significant figures. And all it is rounding off for numbers that aren't decimals, or sometimes they are as well. But often when we've been rounding numbers, it'll be something like round to 2 decimal places. But in the real world, that doesn't come up as often as actually rounding to significant figures. Let's say we're talking about driving to Melbourne, and I asked how many kilometres it was. You might say 800. But it's not 800 exactly. You're rounding off to the nearest 100. Or you're chopping it down, so you're only giving me one number that's descriptive, and the rest of them are zeros, just to tell me how large that number is. And that's what we would call one significant figure. You might as well do it when talking about, say, distance to New York or something like that. You might tell me how many thousand kilometres there are, but only put one number in front and the rest are zeros. You round it off to one significant figure again. So let's have a look at how to count how many significant figures there are, and then we'll have a go at rounding off as well. And then the main point of this exercise is using them in combination with scientific notation. So to count significant figures, we often write sig figs, just because it sounds fun to say. To count significant figures, begin counting at the first non-zero digit. So the first number that's not a zero, start counting and keep counting at the first non-zero digit and end at the last non-zero digit. So there might be zeros in the middle there, and so we have to count them, but just say the number was 202,000. Those last three zeros we do not count. We ended at the last non-zero digit, which was a 2. So let's have a go. How many, e.g., sig figs? A. Let's say 3284000. How many? Well, we start counting at the first digit that's not a zero, which is this one. And we're going to end counting at the last non-zero digit, which is that one. So 1, 2, 3, 4. That's not right, equals, because it doesn't equal 4, but you'd write 4 sig figs. 4 sig fig. B. 440,240. Counting from the first one that's not a zero and ending at the last one that's not a zero. 1, 2, 3, 4. 4 again. I've got to come up with some more diverse examples, but you can see here there was a zero in the middle and it counted. Because I obviously haven't rounded off to this zero, have I? So I wouldn't have then had some more numbers that weren't zeros. C. 0.003054. Alright, how many of those are significant? Well, start counting at the first digit that's not a zero. Oh, I've done it again. 1, 2, 3, 4. Alright, I'll try harder this time. Come up with one that's not a zero. Let's say 6.28 times 10 to the 4. So I'm chucking my number in there. Maybe to be deliberately confusing, we'll see. If I was to write this in, well, the 4 is confusing because it's a horrible 4. If I was writing this in my decimal notation, I'd have 1, 2, and then 2 more zeros on the end. So 62800. You can see there's 1, 2, 3 of them that aren't zeros, and then the rest are zeros. So 3 sig fig. Now, when we round off to significant figures, it's the same as decimals. We're looking, what's the next number? Is it 5 or more? Round up. Is it 4 or less? Round down. So, what do we say? What have I done? I've changed the scale immensely. Somehow. There we go. Alright. Right to 3 sig 4 9 8 6 7 3 8 2. Now I need to write this to 3 significant figures. So I'm starting counting here. 1, 2, 3. So the rest of them need to be changed to zeros. I need to look at this number here though. Does that round up or down? Well, 6 rounds up. So that 8 is actually going to be a 9. 4, 9, 9. 1, 2, 3, 4, 5 zeros. So I've rounded that off. These are the significant ones. The rest of these zeros are just telling us how large this number is. Let's have another go. 0.003 9 9 7 4 1. So I start counting at my first non-zero digit, which is the 3, and I count 1 2 3 because I want 3 significant figures. Cut off here 7. Right, that rounds up, which means that becomes a 10 and carries over, which means that becomes a 10 and carries over. So this is going to be 0.004, technically 00. And normally with decimals, we wouldn't write that. But because we know we wanted 3 significant figures, I have to put these here to show that I have rounded off to that many decimal places or that many significant figures. If I just left them blank, then we might think that I only wanted 1 significant figure, which is not what the question asked. Alright, let's do this one. Let's see. Let's do 1, 3, 8, 2, 2, 5. I just thought I'd choose this one just for a bit of mix up. 1, 2, 3. Look at the next one. 2 rounds down. So that stays the same. We hadn't had one that rounded down yet. 3, 8, 2, 0, 0. So pretty simple. If you know how to round decimal places, you're going to be fine to round these as well. But let's combine it with some scientific notation. So right to 2 sig fig in scientific notation. A 3 6 1 9 4 8 2 0 3. All right, I want 2 significant figures. 1 2. That's a 1, so that's staying the same. Scientific notation, we remember, I wanted to write a number between 1 and 10. And I've had to move the decimal point. 1, 2, 3, 4, 5, 6, 7, 8. All the rest of them, all of these become zeros. And in scientific notation, when we times by 10 to the 8, they will all be zeros. So we're kind of doing both steps in one at that point. All right, let's do a really small number. That's not a small one. 0.00003. Already chose the 3. 80641. All right, I need to start counting at the first non-zero. This one. I need 2 significant figures. So 1, 2. This one rounds off to 8, 1. 8.1 to make that a number between 1 and 10. How many times did I have to move the decimal point? 1, 2, 3, 4, 5. Times 10 to the 5. But this is a really small number, so I was actually dividing by 10 to the 5. So I need my negative there for the really small number. All right, have a go at those exercises. You'll see at the end of last video, I did an example on the calculator, and that comes up again in this one. I knew those questions were going to be hiding somewhere. It's actually in today's exercise. So if you need refreshing on the calculator, just using the 2 times 10 to the power of, say, 8. You need refreshing on that, go look at yesterday's video. Thanks.